Hello everyone, so I'm going to start class 4, and this is all about the router and the routing protocols. So we'll start with the router. Routers use headers and forwarding tables to determine the best path for forwarding packets, and they use protocols such as ICMP. So as I've already discussed, a router is used just to forward a packet. It routes a packet. And a router is connected to at least 2 networks and decides which way to send each information packet. A router is located at any gateway where one network meets another. This is similar to where the internet meets the internet, and it includes each point of presence on the internet. A layer 3 switch is a switch that can perform routing functions. So next we're going to look at the broadband router. So what is a broadband router? Broadband routers can do different types of things. They can be used to connect to the computers or to connect to the internet. If you connect to the internet through the phone and are using voice over IP technology, then you need a broadband router. So if you're connected through the internet and you're using telecommunications, then you would need a broadband router. So now we're going to look at a wireless router. So this is the type of router that we see most often nowadays. A wireless network creates a wireless signal in your home or office. So whenever you are getting a wireless signal, that means that they have used a wireless router. Any PC within range of a wireless router can connect and use the internet. So in order to secure your wireless routers, you simply need to secure it with a password or get your IP address. And when you log into your router with your user ID password that comes with your router, then you can access these settings. For all the settings, you have a router panel. This can be accessed through your network. It will run in your browser by using the default gateway and the default IP address. Then you can change the settings for your wireless router. Then there's the core router. So this is a router that resides within the middle or backbone of the LAN network rather than at its periphery. In some instances, a core router provides a step-down backbone, interconnecting the distribution routers from multiple buildings of a campus. So when you are using multiple buildings and you need to connect them, this is the type of router that you would use. So next is routing. What exactly is routing? Because we've already discussed routers and the different types of routers that we can use. Now we should probably look at what exactly routing is. In internetworking, it's the process of moving a packet of data from source to destination. And this is just a simple definition: moving a packet of data from one source to a destination. Routing is usually performed by a dedicated device called a router, which we've already discussed, and each intermediary computer performs routing by passing along the message to the next computer. Now, routing is often confused with bridging, which performs a similar function, but really, routing is nothing like bridging. Bridging is the concept when you are going to use multiple networks. So in case I want to connect one network with another network, say I have complete network A and a complete network B, then I will connect them with a bridge, whereas routing is within a network. Static routing. So next is static routing. What exactly is it? So here the router learns about remote networks from neighbor routers or from an administrator. The router then builds a routing table. So every router has its own routing table in which they know how to route a packet from source to destination. So it has a complete routing table. If the network is directly connected, then the router already knows how to get through the network. So in case I'm talking about your internet, it has all knowledge of all the IP addresses, so it knows all the network connections. And so the routers then update each other about all the networks they know. Dynamic routing. So dynamic routing performs the same function as static routing, except it is a bit more robust. So dynamic routing allows routing tables and routers to change as the possible routes change. It works dynamically and it changes their path. So there are several protocols used to support dynamic routing, and these include RIP and OSPF. We will discuss these later. Dynamic routing is when we are accessing or the router is updating the routing table again and again, and that is dynamic routing. Routing protocol. The purpose of routing protocols is to learn of the available routes that exist on the enterprise's network. Some of the most common routing protocols include IGRP, EIGRP, OSPF, IS_IS, and BGP. These are the routing protocols. There are two primary protocol types, although many different routing protocols are defined within those two types. When a route becomes unavailable, all router tables must be updated with that new information. So when you're trying to get the route, just update the routing table of that router and you'll be able to get connected. Next is Interior Gateway Routing Protocol, IGRP. So we already know of IGRP, EIGRP, OSPF, ISIS, and BGP. So we're going to look at IGRP first, Interior Gateway Routing Protocol. So IGRP is a distance vector routing protocol developed by Cisco Systems for routing multiple protocols across small and medium-sized Cisco networks. This contrasts with IP-RIP and IPX-RIP, which are designed for multi-vendor networks. IGRP does recognize assignments of different autonomous systems and automatically summarizes at network class boundaries. There's also an option to load balanced traffic across equal or unequal metric cost paths. So IGRP is used in the Cisco networks. So next is EIGRP, the Enhanced Interior Gateway Routing Protocol. So EIGRP is a hybrid routing protocol developed by Cisco Systems. It has characteristics of both distance vector routing protocols and link state routing protocols. It is proprietary, which requires that you use Cisco routers. And so this is only able to be used on Cisco routers. EIGRP will route the same protocols that IGRP routes, that's IP, IPX, DECnet, and AppleTalk. Finally, we have access control protocols. There are many reasons to configure an access list. So for example, you can use access lists to restrict the contents of routing updates or to provide traffic flow control. And one of the most important reasons to configure access lists is to provide security for your network. You should use access lists to provide a basic level of security for accessing your network because it essentially determines who has permission to access the network and who doesn't. It's a complete list of all the IP addresses which have access and which do not have access. And so when you have multiple IPs trying to get access, it can determine which ones are to be blocked. So it can block external IPs, and it can block anything that is not on the list or is on the list to be blocked because it is a complete list of those that have permission to access and those that don't. And so that's it for this class. Thank you.